So I was saying that this particular table is looking at the difference in the mean between males and females for the variables age, anthropometric measures, hemodynamic measures, and the biochemical measures. So the question that this particular table is answering is that when we take the age of males and females, is the mean age of males and females, are they different or is it different? And then the answer is what we find in the p-value. So when the p-value is significant, then it tells you that the difference in the mean age of male and female is different. When you look here, you see 49 and then 51. 51 is greater than that of 49. So what it means here is that males had a lower age compared to females. When it comes to weight, for example, is the mean weight of males different from that of females? The p-value here is saying no. The mean weight of males is 75.8 plus or minus the standard deviation. And then the weight of females is 75.6 plus or minus standard deviation. And these values are very close to each other. And so it makes sense why statistically we are saying that there's no difference, significant difference. The same applies to the height. The height of females is lower than that of males. The BMI of females is higher than that of males. And then the waist circumference of females is higher than that of males. The hip circumference of females is also higher than that of males, whilst the waist to hip ratio is somewhat the same or comparable. So that is how you are going to do the interpretation. So you are going to say that for this anthropometric measures, so for the anthropometric measures, the waist and waist to hip ratio of males and females were statistically comparable. How highest one, the higher one. This one is higher. This one is also higher. And this one is higher. So it makes the sentence very simple. So we're going to say that for the anthropometric measures, the weight and then the waist to hip ratio of males and females were statistically comparable. However, the height of males was higher than that of females. And we'll put this p-value in brackets. And then we'll see, whilst females had a higher BMI, waist circumference, and hip circumference than males. Then in each case that we are mentioning the variables, we'll put their corresponding measure values and then the p-value in brackets. So that is how we are going to do the interpretation. So maybe let me write that one for this one. So we'll see that the anthropometric measures the weight and waist to hip ratio of males and females were statistically comparable. However, the heights males were observed to be taller than females. So males were observed. So we can put into brackets here the value. So we copy this. And here then we test. taller than female. Then we'll put the females one in brackets. Then, then we also add p-value equals to 0.0001 less than females also females also had higher BMI. Then we put this one in brackets. Females also had higher BMI. Waist circumference, hip circumference, okay, and their counterpart males. So we have to put all the units by them. Define exponent 2 centimeters. This is also centimeters. There are different ways to write these sentences. Another way is to say that, however, males, okay, yeah, it's taller than. Then for this one, because they are more, you can see that comparing males to females, female had a higher BMI. Then you write, so the same sentence. Let me do it. So I'm doing this one again, this part. I'm changing this part and writing it in a different way. So comparing males to females. Females had higher BMI. So here we put this one. Then we see versus. We see versus. So I don't want it to go. Versus. Then we'll put the male one. The BMI for and then comma WC. WC. And WC, then we'll do the same, the way we written this one. We write this one versus versus WC. Mind you, we have to add a p-value, so I don't know why this always wants to we put the p-value equals to less than 0.001. Bracket counts. Less than 0. WC, the p-value is what? 0.03. And then for the WC, it's less than 0.00. Okay, so this is how we can do the interpretation. So with this idea, you replicate it for the significant ones. So you do all this hard work for this versus that's the p-value for only the significant ones. The non-significant one, you can just see as captured in this sentence. Yeah, you can just write that they are statistically comparable. If they are not different, statistically different, then they are comparable. And scientific studies, we are interested in looking at differences. So that is why we pay attention to abnormalities or things that are not the same. So usually we focus on where there's difference. So here HB is different, it's higher among males than females. This is a normal observation because we know the physiological background, and then this and this. So basically, that is how you can do interpretation for this particular table. And the test that was run for this is an independent sample t-test to compare the mean of this. So once mean has been used here, it means that all these variables have passed test of normality and they are normally distributed. And so we can represent them using their means. Had they been uh, not normally distributed or non-parametric, we have to rely on their non-parametric um, versions of the independent sample t-test, which will be the Mann-Whitney U-test. So where you compare their median instead of their mean. And instead of adding plus or minus standard deviation, you have to put into brackets the interquartile range or further advanced mathematics or statistics. You have to add or subtract the median absolute deviation, which is the MAD. So basically, that is how you can interpret this particular table of independent sample t-tests.
If you are new to the channel, we encourage you to subscribe to the channel and turn on the post notification bell so you are always notified whenever we release a new video.